Welcome to Examining Origins. I'm here with Dr. John Gideon Hartnett. He's a physicist and he's been a physics professor and he's done a lot of other things. And he's going to be sharing with us some shocking truth about cosmology. So take it away, Dr. Hartnett. Thanks for being here.
Okay, so I press, how do I get this to go? The slides I'm talking about?
Yeah, you can present.
I've already uploaded it, right? So
yeah. Oh yeah, you here, I will add it to the stage. There you go.
Okay, so yeah, all right, so here we go. And so I'm just going to follow through these notes and for the first segment, and then we'll go more interactive after that. Cosmology is not science. Now, to a lot of people, that may sound a bit shocking. But in cosmology, some hypotheses, in fact, I would say all hypotheses in cosmology cannot be tested. And if something cannot be tested, it's not science, not in the operational operational science, in the way operational science should work. And I'll explain a bit more as we go. Well, all cosmology is like this. It cannot be tested. And in this case, it's really a religious belief and not science. In fact, I contend that it's even a pagan religion. And that means you have a choice between one religious belief or another. I choose the biblical worldview, knowing that it is also a belief system. Now, this is a quote here. This is published in 2007 in the Journal of Science by, I'm going to give you quotes from two eminent cosmologists. James Gunn, who is of Princeton, who is a co-founder of the Sloan Digital Sky Survey, which was and probably still is the largest all-sky galaxy survey. He said, cosmology may look like a science, but it isn't a science. A basic tenet of science is that you can do repeatable experiments, and you can't do that in cosmology. And then Michael Turner, also cosmologist, he says the goal of physics is to understand the basic dynamics of the universe. Cosmology is a little different. The goal is to reconstruct the history of the universe. So you see, cosmology is more akin to evolutionary biology or geology, and in which researchers must simply accept some facts as given. I mean, that's an honest revelation. In science would probably be either the first or second top science journal in the world, and sometimes this truth gets out. Now, my analogy here of the four blind men is not a perfect analogy, not a perfect metaphor, but it's fairly close. You got four blind men feeling different parts of the elephant, and they all come up with different interpretations of what the elephant is. Cosmology is slightly different, and this is where this particular analogy breaks down, because the data, the observational data for the universe is the same to all observers. But in this case, we can say the universe is underdetermined. That means there's more than one physical theory that could describe the same observations. And therefore, no theory that can be concluded. In other words, you can't conclude that any one of those particular theories represents reality, because there are multiple possible theories to describe the same observations. And this is a serious problem, and I don't think it's ever going to go away. Now there's the scientific method. Now we often hear this talked about, the Baconian system of hypothesis, prediction, and experiment. So in the sense of repeatable, testable measurements in what we call operational science, this is a myth. Never did I ever experience such a classic method in all my years in experimental physics. If anywhere, that is where it should be, in an experimental lab. I mean, if anywhere you're going to use that method, that's where you should be using it. What actually is used is called Bayesian, the Bayesian method. And Bayesian method really is a reliance on past experience. So it's a bias, it's an observer bias, where you build on what you have previously done. I mean, there's even a bit of a joke in physics when you're applying for a research grant that you're far better off applying for a grant for research that you've already done, saying that you're going to do that research. That way you can say what you expect to get as your outcome, because in the grant applications, that's what you're expected to predict, to write. And so that's classic Bayesian, because you're only building on your past experience. So the Bayesian method could be called a prior assumed belief in the experts. So the experts must know what is correct, so we'll just build on that. So there's what this results in a sort of a leaning on the experimental evidence to get a desired outcome. And you can see that easily can lead to a corruption in science, very easily. Now, this is published in 2015 in The Lancet, the medical journal. It was an article called a lot of what is published is incorrect. Now, this is in the field of medicine he's talking about. But before I read those comments, I years ago read an article in Nature, the journal Nature, where it claimed even up to 90% of medical, physiological, biological sciences publications are wrong. This one was in the Lancet medical journal, where it claimed over 50% of the work is unreproducible. And these comments are from the author, Richard Horton. He said the idea that something has gone fundamentally wrong with one of our greatest human creations, and that is that these publications, these so-called results, 50% of them are not right. Much of the scientific literature, perhaps half, may simply be untrue. Scientists too often sculpt data to fit their preferred theory of the world, or they retrofit hypotheses to fit their data. And that's very Bayesian, where you're sort of not prediction, but you're like post-diction. You're looking back into what you already have, and then you're modifying your theory to fit that data. And you can see that from this, no one is incentivized to be right. And that's particularly true of grant applications. Publications bear heavily on your next grant application. And so you want to show that your experiments so far are sort of fitting what is expected. It's all, it's all pretty shady stuff in a lot of ways. So beliefs, therefore, dominate the research, and this can lead to fraud on a mass scale. And I think in some of the medical type publications, research papers, which rely heavily on data analysis, statistical analysis, it's very open to fraud. But this is also true in the hard sciences. I recall one time at a theoretical physics conference meeting a guy, I don't remember his name right now, where he developed his own theoretical physics theory. It was called something like E-theory or something like that. And I sat through a couple of his lectures, and at the end of them, I couldn't understand a single thing that he had said. few months later, someone I knew quite well in association with some of those people, he told me this guy had been outed as a total fraud. He had created his own physics journal, which a lot of people were publishing in because it had quite a high impact factor. And yet it turned out that this guy had been using some of his friends to publish his own papers, his own research in his so-called E-theory, and it was all completely made up. So he was eventually outed and the whole thing was shown to be totally fraudulent. But all fields of study have the same problem. It's not just in the softer sciences, but it's true in the hard sciences as well. All so-called science is limited by the beliefs of the researchers involved. Their beliefs dominate the research and their public findings, and there's no secret about it. No one's trying to hide that. Maybe that particular guy did. So this is a joke, but this is true. A university professor tells his students, fully 80% of the stuff you'll learn at university is wrong. The trouble is, we don't know which 80%. And that, I know that's sort of a meme, that's sort of humorous, but that is very true. And it's even more so in cosmology because of its untestability. So what is truth, we might ask? Well, there's no such thing as an open investigation for truth. That doesn't exist. It's always corralled into some restricted zone where only certain outcomes are permissible. Again, I can tell another story where I was publishing some research in cosmology in using an alternative cosmological theory of Professor Moshe Carmeli from Ben Gurion University. And it was controversial. It was not liked or accepted, but I was able to publish in a few theoretical physics journals. And these were classed as like lower level journals, not such high impact factor. And one day I was called to the head of school in School of Physics at UWA, where I was working at the time. And the head of school told me that me publishing those sort of lower level journals, put it that way, was having an impact on the university, I should say the school's funding model, because publications in the higher impact factor journals will raise some sort of brownie point, some sort of score system upon which the school gets judged to get funded. And so he was telling me you should stop publishing on that theory in those journals, which really meant stop publishing on that theory at all, because they were the only journals that would allow it to get passed through. So it's the humans that control this. But how can humans become the final arbiters of truth, of what is truth and what isn't? I mean, if you say they are, then that's like being omniscient as the creator. Now I want to look at 3 areas of history, and I say they're history. All are religious beliefs because all are untestable. And this might be a bit surprising to you. Firstly, it's the history of the universe, and that is untestable. Cosmology, which is really about the structure of the universe, is just stamp collecting, and I'll explain what I mean by that. So it's like a collection of different types of objects. So these are my stamps in the collection. And astronomers might catalog them, characterize them into different categories, redshifts, their luminosities, their spectra, a range of properties. With stars, it might be color, size, magnitude, this sort of thing. So the astronomers collect stamps of different types and assemble their collections to try and support They're religiously held belief systems, and this is what they call their theories. Number two, the history of planet Earth is untestable. This is going right back to the alleged origin of the Earth 5 billion years ago out of some planetary nebula system, and the sun formed and the planets all formed. That's the alleged history back then. But geology is also just, well, I call it here rock collecting. It's very similar to cosmology. There's no access to the past. It is gone forever. All theories and models, including all those with biblical or religious underpinnings, are untestable. So all beliefs, biblical or otherwise, that is biblical or secular, are only held by faith. There's no special privilege to the secular or to the religious, whatever the underpinning might be. I mean, it's not just from the Bible, that can come from other biblical, religious sources. They're all untestable. And then the third one is the history of life's origin is also untestable. So that's about the spontaneous organization of a living cell from some organic chemicals in a warm pond in a past one-off event, unobserved event. I say putative there because I don't believe it ever happened. As such, it is untestable. So following that, there was the alleged Darwinian evolution of that organism, one organism, in fact, into another in this sequence, time sequence over billions of years, and that is also untestable. So these ideas all fall into the category of religious beliefs. They call it science, which means that science must be a religion. Now, in contrast to that, we have operational science. This is not historical science. It's not forensic science. Operational science is testable and repeatable. And the theory of gravitation is a good example. It is also limited, though. So it is spatially limited to the solar system. Out beyond that, it's back to stamp collecting again. And there are good examples of this where our theories don't work. And I cite one example here, galaxy rotation curves. Now that's where, if you look at spiral galaxies, the speeds of the stars and the gases well out beyond the central nucleus of the galaxy, they are, from their redshifts, they are apparently moving too fast. And if over millions of years, if they continued to move at those speeds, the galaxies would dissipate. So the assumption is, of course, the galaxies are being held together over billions of years, and therefore we can't explain that with standard Newtonian physics. So in this case, it doesn't matter how many examples we collect, like spiral galaxies, for example. We cannot test the theory on the universe. We cannot test any particular alternative theory even in the universe because we can't interact with the universe. We are limited by collecting more and more examples and developing ideas to try to explain what we observe. Now we develop cosmological models, and we can develop these, we can propose these, but we need to test them against observations. Testing them against observations does not mean you're doing an experiment on the universe like a physicist might do in a lab on a bench. He can interact with his experiment. He could send a light signal in and see what comes out and see what his model predicts. But with the universe, you cannot interact with the universe. And hence, in this case, we're limited to the statistics of our stamp collections. That is, maybe the galaxies, the redshifts of those galaxies, their size, their luminosity, and so on. That's all we have. But this also does not mean that a cosmology, that is a theory to describe that structure of the universe, it doesn't mean it can't be ruled out. It may fail to meet the test of the observations we have. And this is a very example of where this has happened is the 1998 publications by two teams claiming not only is the universe expanding, but it's accelerating. The expansion is accelerating. And they came to a point where, using the standard cosmology at the time, they got a contradiction. And that contradiction was that the fit to the high redshift supernova measurements that they were using as a standard candle meant that the mass density of the universe must be negative, which of course makes no sense. Now, if I can relate that back to being an experimentalist in a lab, the experimentalist would say something's wrong with the theory. But that's not what happened when these two teams, the high redshift supernova team and the what was called Cosmology project or something like that, they both came up with the same result. And so they added back in Einstein's cosmological constant, which meant that you have a new force in the universe, often labeled dark energy, some sort of an anti-gravity. It's a type of energy that doesn't exist in any lab, Earth-based lab. And yet that type of insertion into the equations was required to get the theory to fit the observations. And so you have, what I say is, because of those religiously held beliefs, the model is retained and the hypothesis or hypotheses are added to keep it alive. These are ad hoc or auxiliary hypotheses, and we see this many times in science where, at the time of Galileo, they often spoke about epicycles were being added. And this is the same thing as auxiliary hypotheses. And that's exactly what dark energy or the cosmological constant is. So our best theory in experimental physics is the standard model of particle physics. I'm not sure exactly of what the number is now, but that theory has been able to predict the masses of certain particles, or calculate those masses, I should say, maybe out to as far as like 10 decimal places. And that's a very good theory that can do that. But it's a complete theory, and there is no dark matter particle in the standard model. It doesn't exist. In fact, the standard model contradicts observations on the Big Bang model. And these are in a number of areas, but one area is the discrepancies in the alleged Big Bang nucleosynthesis. So new dark matter particles, or at least one, the sterile neutrino, is proposed to try to get solve that Big Bang problem. And of course, this leads to debates and the necessity of adding additions in theoretical physics. So we have nowadays what we call the standard model extension. The standard model has been extended into the dark sector with a whole host of putative particles, none of which have ever been detected. And I'll speak a bit more about that here. So there's a whole new industry that has developed looking for hypothetical, fictitious dark matter particles. I spent 18 years at the University of Western Australia. In fact, I worked in this lab, which it wasn't part of this a larger group, which was called Quantum Technologies and Dark Matter Research. At that time, it wasn't, but it is the same lab with the same team under the same head scientist. I worked with them, and some experiments we did when I was there were looking for putative dark matter particles. The one I worked on was the paraphoton, which you could call it a dark photon, even if you wish. I know it's starting to sound silly, but these experiments look for dark matter particles over enormous range of energies or mass, and enormous amounts of money is being spent. I mean, this group would have been funded through Australian Research Council. I don't know the numbers, but the numbers are typically many millions of dollars to fund this type of research. So I say it's a new industry looking for something that doesn't exist, and it will keep certain people gainfully employed, and then at least they're not on unemployment, and the students are learning new skills. And I applaud that, actually. They're learning a lot of new experimental physics skills, even though it's kind of sad in a way. They're looking for something that doesn't exist, and it doesn't even exist in the standard model of particle physics. That's the amazing thing about it. So the point I make here then is you cannot know the truth from science. You know, if you say that mankind can in principle discover all truth, that it means mankind has become as gods, or he has become God. So there are fundamental barriers in place that prevent us from knowing all truth about the natural world and the history of the universe. I mean, history is fairly easy to understand because we have no access to the past. No one has ever invented a time machine, and it's fairly simple to understand that that cannot happen. You have all sorts of paradoxes if you even believe that can happen. Everything we do is in the present. We live in the present. Our existence is all in the present. All evidence is in the present. So to know something about some truth with inverted commas, about some past event, there's nothing you can do in the present to experimentally determine what that is. Sure, you can propose a theory, you can make measurements, and you can say these measurements are consistent with this idea, but you cannot make absolute truth claims based on that. So science is a useful tool if you understand its limitations. Otherwise, it's pagan religion where man essentially has become a god. Science is a religious belief. And this is true of nearly all so-called science. I say nearly all because, I don't like to make absolute statements. But cosmology, cosmogony, which is the history of the universe, astrophysics with all sorts of fudge factors, dark matter, dark energy, dark photons, dark radiation, dark planets, dark galaxies, and dark life. I mean, these are crazy ideas. Geology, including the planetary history of how, the solar system or all solar systems form. Biology and the origin of life and the origin of all life on Earth, and medical science. These are all areas which really involve religious beliefs. Science is an agnostic religion, is a belief in what the experts, that is the priests, the high priests of the science, say is reality. And today science has become an idolatrous belief system. The priests in white coats, white lab coats, define what is truth. The masses are taught to love it, to idolize science, follow the science. I mean, there was a few years ago, we had a sort of a medical event swept all around the world where they told us to follow the science. And a certain doctor in America was called Mr. Science. I remember there was one lady on TV here, Australian medical scientist, saying, we're proceeding at the speed of science. That doesn't make any sense. That's just nonsense. So these Gnostic beliefs, they lead to people people who claim to believe in the history of the Bible have fallen into a trap of believing in this Gnostic science. So I'm talking about many people in the churches who claim the biblical Genesis history is described by the Big Bang universe, that we see in that history an interpretation of the Big Bang or Darwinian evolution. So this is a sort of a Gnostic science in this generation, theistic evolution. And this includes the Big Bang origin of the universe, the origin of life itself from that pond scum that over 4 billion years turned into particle physicists, astrobiologists, or whatever. Darwinian evolution, that stepwise increase of information over billions of years. This is all Gnostic religion, and it truly has entered the churches. Now, I'm not advocating a chaotic system. I'm not advocating, in other words, that we give up on any scientific methods or approach. I believe God created the only true rules-based order. That is, the laws of physics, the laws of nature are ordered, reasonable, and stationary. They don't change. And we rely on this in our daily lives, the fact that they don't change. But many in the corporate church have departed from this correct history and science, the science described in the biblical account, because the reason they've departed is because of modern science, so-called modern science. I should put that in inverted commas, because I'm saying that is not science. That's the pagan religion that they are following. So that's where we are now in this time. The church has been mesmerized under the spell of the Eye of Sauron. I'm sure there are many was it Lord of the Rings followers out there. And this is basically the same with the rest of the world. They're under this sort of spell. And the love of or obedience to science has become idolatry. And that's exactly what it is. You know, that's like those statements. So we're following the science, or we're going at the speed of science. No, they're following their religiously held belief system, and maybe what their overlords or their bosses, those who tell them what they should be doing, that they are ordering that system. Because I mean, it might involve research grants, it might involve their job. Who knows what it involves? So the true biblical history is given to us by the Creator. This is discarded in light of what those dark lords of science say is the truth. I mean, that's absolutely what's going on. God created the universe less than 8,000 years ago. He created man in his image. He created only male and female, only two sexes. And thankfully, the UK High Court has finally realized this after at least, 5,000 or 6,000 years of human history. They now say that a female is one born a woman is one born biologically a female. Well, you know, it's well known. I don't think there was any secret about it. God created the laws of nature, and he gave us order and not chaos. Christ, rejecting humans, have departed from this worldview, and even most of those in the corporate churches have also departed. They have no idea that they are under the spell of Sauron. You know, in the scriptures, Jesus himself spoke of this issue to do with male and female. He spoke of it, in the beginning, God made them male and female. So I don't think Jesus, the creator of the universe, was under any spell of the eye of Sauron. He was telling us the truth. Okay, from this point on, we will go into a bit more cosmology. Previously, I know there was a lot there, but it was more general to science. And so at this point, Rebecca, if you want to interact a bit more, that's fine. And we'll continue with this.
Yeah, I would love to just pause here because I've been taking all this in, and there's, you know, a few things that I'm like, I so agree. I mean, a lot of what you said, I totally agree with. A couple things I want to kind of give a little pushback on, but I like when you're talking about the way that, you know, people are under this spell of Sauron and stuff. I see that so much in that even when people are presented with scientific observations, somehow it doesn't even crack their belief system in the origin of life. You know, no matter how much science contradicts the idea of you know, pond scum being able to form itself into living organisms, they are so religiously held by this belief. And I even see it like I'm having a weekly show with my brother, and I feel like I have presented him lots of good evidence that these are not things that can come about by material processes. And I recently asked him, like, Nathan, has this cracked your faith in evolution? He said, no, not at all. And I thought, oh my gosh, it does feel like he's under a bit of a spell. And I mean, there's, like you said, it's in the church. Lots of Christians totally believe this. So yeah, that's and I'm okay. Like if somebody is able to maintain their faith in Jesus, I'm not going to make an issue about their belief in evolution, but I want people to know the truth about reality. So that's why it's important to me to share the truth about reality. And one of the motivations is because I do think people are deceived by these ideas, and they are locked into a religion and they don't realize it. Right. And it's a cult. It's actually a cult religion that they are blindly following. Yeah.
Yeah, of course, I'm not trying to criticize someone because they may have a falsely, like I'm talking about a Christian, a believer. Someone may have a falsely held belief system. The issue is, like you're saying, that belief system is inconsistent with the biblical worldview that the Bible presents. And so it's illogical. And it's something that we should try to correct them with using the biblical sources to help them understand that it's a worldview issue. It's not a science issue. It's not like science is going to fix the problem. It can't, because all scientists, secular or religious, and I mean to include of other religions as well, all hold their own worldview. And that worldview is, if you like, that's like the glasses through which they interpret all the evidence, all the observational evidence or experimental evidence. And so that's part of the problem. So if we can convince someone or show someone that the biblical young earth creation account from the Bible is consistent with the the rest of the history of what's in the scriptures, then it will, as I've seen many people this has happened to, it was like a light going on in their brain, which then tied everything together. They realized that Adam and Eve were real, and Adam's sin was real, and that sin had an impact on the whole universe. And that's why we needed a savior. And that's why Jesus had to be born, the second Adam, to redeem us and pay that price. But if Adam, the original Adam, was a metaphor, it doesn't make any sense. It's like a nonsense story. And so, yeah, I agree with what you're saying. I'm not trying to indicate that these people, just because they believe in the Big Bang, are unsaved or something like that, but they're illogical as far as a biblical believer goes.
Yes.
As far as a non-believer goes, they are actually consistent with their worldview, because they don't believe in the creator. Instead, they create their own God, which generally is themselves.
Yeah. Okay. Now I want to kind of get some clarity, because there was a little bit that I was confused about, because at one point you said science is a religion. Do you mean just the way in which it's being done right now, where it's based on theories about the past? Because then you also said operational science is something different. It's good. We use it. We are able to test things. So when you say science is a religion, are you only talking about the science that proposes to be able to tell us about the origin of universe, origin of life, etc.?
No, I'm actually referring to all science. Okay. Now, I do, as I said, there's limitations of science, and it's good when it's used and we acknowledge those limitations. But for example, let's not talk about the past. Let's take an example about talking about something in particle physics, that we have experiments we can do in particle physics. And a very good example of this is the search for the neutralino, which was the lowest energy or lowest mass supersymmetric particle from SUSY supersymmetry, that at the Large Hadron Collider, they tested for 10 years of continuous runs. It was more than 10 years, but they're effectively 10 years of runtime. And a team of theoretical physicists, after the 10 years, they took the scientific method honesty approach and said the theory has failed. And that should be applauded. But there's a group of them also in the same category of that type of theoretical physicist who absolutely refuse to accept failure. And so this is where this was experimental science, where they were testing for a theory, a theoretical physics model, and some of the advocates will not give it up. They will say, we need to go to higher masses, or we need to, we need to fish around in some parameter space looking for these fictitious particles. Now, that's not uncommon in experimental physics, or I shouldn't say just physics, I should say experimental sciences, because this does happen. So this makes it a religion also, because they're holding on to it by a belief system. So that's sort of stepping outside the limitations of the scientific method, because they've got a refutation of the theory and they fail to accept it. So we need to be careful. It's easy to see when you're talking about history, but it's not always so easy to see when we're talking about testing some theory or new theories in lab experiments.
Okay. And then I guess there's so much we could talk about, but I just, since you brought it up, wanted to bring up and just kind of give a little bit of pushback about what the male female, because I totally agree with you. God created male and female. Even Jesus reaffirmed male and female. But then what do you do with the reality that, like, there are things that happen just in the same way people are born with like a cleft palate, and God didn't, originally
Yeah.
create cleft palates. We have, interesting things that are happening where people are born with, some parts, that are male, some that are more typically known as
Yeah.
female. So not everyone fits exactly right into
Yeah.
that male-female division.
Okay.
Mhm.
Can we talk about that then a little bit?
Yeah.
And the best way to talk about this is getting definitely away from cosmology, but
Yes.
let's
Well, you
talk about.
introduced it, so I thought maybe you would be okay with talking about it just for a bit. Yeah.
Okay. Let's talk about XXY and XYY chromosomes. Now, in a lot of schools in Australia, I don't know about the US, it's possibly the same, they were using the occurrence of, this is a genetic defect that occurs in some children, some born babies, where they have an extra chromosome. They have a Y, but they have instead of an XY, they'll have an XYY, or they'll have an XXY. And the occurrence rate is about 1 in 1,000 of male babies. When we say male, we mean they have a Y chromosome. 1 in 1,000. Yet schools were implementing these policies, which are, well, what were they called? Anyway, safe spaces for alternately identifying children based on this type of chromosomal error. But even in a large school, Australian large schools are only like about 2,000. That's a big school here. That would only mean statistically 2 children in the entire school. So to get the entire population of the school to modify its behavior for a statistically small number, which are, I agree, come from the curse, come from a defect. It's not part of the original design. And it's because of Adam's sin, God cursed the laws of the universe, cursed the whole universe. And unfortunately, these children are born this way. And we need to have compassion and we need to accommodate them. However, in both cases, they have a Y chromosome. And in both cases, most of them will never know that they'll identify as a male through their entire lives. This is all scientific studies have shown this. And only some of them who have the extra X chromosome, XXY, will be more effeminate than the other one, which has the extra Y chromosome. So that the differences are very small, and their lives are generally normal to the point, unless medical tests was done, they wouldn't even know. Now, this is true. Now, then when you get to what you mentioned, an extra, opposite, have both genitalia, hermaphrodism, that occurs at the rate of 1 in 10,000 chromosomally, 1 in 10,000, again, due to mutational error, genetic defect. And so statistically speaking, you would have to have a school at least of 10,000 students to have one occurrence of one. Why are we changing the entire Western culture for this sort of thing? We need to have love and compassion, and we need to take care of these people, and we need to accommodate them, as I think has happened through history once this was understood. But to go and change the entire Western culture seems to be overreach in the extreme.
Okay, thank you for sharing. And I guess I wrote down other notes that I was hoping to talk about, but I want to make sure we get to your cosmology stuff. So why don't we just jump into that and yeah. But I really enjoyed this presentation. And I think it is a little shocking. And so I hope it is eye-opening for people who kind of do have this mentality about science as, just it's the thing we should follow. But I do think we are still saying that science is the legitimate way to pursue knowledge about the world, right? Like,
Yes. I mean,
yeah,
if we keep it within the limitations that I've tried to outline, that we can use it as a useful tool, right?
yeah,
But it has to be interpreted. Even not talking about history here, even interpreting information in a lab experiment, that is subject to the worldview of the scientists. There's a thing that's, for example, the measurement of the charge to mass of the electron is a famous experiment. I think it started with Millikan, and over time, that constant has changed, it would appear, but in actual fact, it didn't. We call this canonical phase locking. So if you imagine the first guy makes an experimental measurement, and then the next guy that measures it again, he says, well, the expert in the past got this number, so if I've got a spread of values, I'm going to choose my value that's closest to what the guy who did it before me did. And so then over time, you'll see a slow progression of that measurement of that physical constant to the true value, the real constant of nature, that has, due to experimental techniques and so on, has tighter error bounds, and we end up with the real thing. So it looked like it changed over time, but actually it didn't. And the reason this occurred is because of a reference, this Bayesian method, a reference to the expert nature of the experimentalists before. So see, that's the limitation. You have to understand that limitation. And so in your experimental lab experiments I'm talking about, do you question what you are observing? Do you question the results? I mean, the many Nobel Prizes have been awarded to lab experiments of the researcher who questioned something that his supervisor said is nonsense. But he ignored that guy and went ahead and investigated some little kink in the curve or some little outcome of his measurements that he didn't understand. And suddenly, lo and behold, he discovered a whole new phenomena, and he ends up getting the Nobel Prize. I mean, the famous measurement of the helical structure, was it Crick and Watson and Crick? They were working in a lab, I think it might have been Oxford or somewhere like that, and they were kind of almost hopeless experimentalists. They were trying to make crystallographic measurements on DNA, and they flooded the lab a couple of times. They did all sorts of things. There was at one point I heard the president or the vice chancellor of the university was trying to get rid of them because they were such nuisances in the lab. And yet their results ended up being the helical structure of DNA. So this is the real situation. We deal with real human beings. And if we understand those limitations, and it works the other way too, right? Where you ignore your supervisor, you ignore the head guy of your group because you've got something there, and he doesn't know it all. He's not a demigod, even though they often act like that. Yeah.
Oh wait, I have a burning question before you go on. Okay,
Yep.
this was burning when you were talking about the standard model of particle physics or physics.
Yep.
The standard model of physics. You were like
particle physics.
Okay, you were like, look, this, like, we have lots of observations of this and it works. I wanted to know, is there anything that it contradicts? Like, I know that it contradicts, like you said, the spiral arms in the galaxies according to the Big Bang model, right?
Okay, just let me correct you.
But okay.
Particle. Just a minute. Particle model. The model of particle physics will contradict the Big Bang nuclear genesis.
Yes. Okay.
The spiral galaxy issue is actually Newtonian physics that they've used for that.
Okay, but is there anything in like that in the in the creation view that is contradicted by our good operational science?
No, absolutely not. In fact, all operational science, I shouldn't say all, vast majority of it was developed by biblical creationist scientists like Newton, um, uh, names escape me at the moment, Faraday, Maxwell. All these people were Bible believing biblical creationists. They saw in the order of the universe the hand of God. They saw the logical, reasonable, stationary laws that don't change over time, which is actually quite contrary to what the Greeks believed. The Greeks believed that the laws could change. And so if you believe that, why would you even do an investigation? Because by the time you finish, the laws may have changed and your measurements have been pointless. But no, because of the Bible saying God is the same yesterday and today and forever, that those scientists carried out that. And no, there are none.
Okay, what about Newtonian physics? Like, I always hear people say, we know Newtonian physics is wrong. It works for us, like operationally here, but we know it's wrong. Are they saying that based on non-scientific assumptions, or is there something wrong, like that we can tell with observational?
Okay,
Like,
so that's again another point I was making,
yeah.
that physics has its limitations. Even let's talk about Newtonian gravity. So the Newtonian gravity has its limitations on scale lengths, that various scale lengths that are outside our normal experience. Our normal experience is, say, the solar system. We can make measurements. When we get out to galaxy scale and you're looking at spiral galaxies, that's where the rotation curve problem showed up. In fact, it was Zwicky in 1933 who first pointed that out. It's got nothing to do with Big Bang LCDM cosmology today. It was long before that. That's just Newtonian physics. And so we would need to explain that. I'm not against the discovery of new physics. I mean, if there is the possibility of new physics on a larger scale, then we should use that. We should test that. But inserting dark matter, halo dark matter, into those galaxies, it was only the beginning of a search for this fictitious these particles, because everywhere in the whole cosmos they're required on every scale, and yet none has ever been detected. That lab I showed you, or the pointed out, the lab that's the it's where I once worked. Wasn't called that then. They didn't have it under that name when I was there, but that's the same lab I worked in. They are looking for cold dark matter in that lab. So that should be cold dark matter passing through the lab all the time. That means those particles are moving very slowly, 10 to the minus 7 of the speed of light. So what's that about? A few meters per second type speeds. That's very cold matter. So, they've never been able to detect anything like that. But those labs are all around the world. So where do you get to the point where you say you give up on looking for that, because that idea as a substitute to explain the anomaly in rotation curves is wrong, right? And there have been others who have approached it without dark matter. There's a couple of different approaches. One approach, a guy modeled all the stars in a spiral galaxy using the many-body problem, which is a very difficult problem in mathematics, or you have to use numerical methods, computational methods, to solve, where he introduced this idea of stellar drag. Stars, due to the Newtonian gravity, no new gravity, no dark matter, you could end up getting the spiral galaxy rotation curves without the introduction of anything new. Another approach was to look at the density of matter in the galaxies, to numerically model it, where the change in the density of the matter, it might be non-luminous, but that doesn't mean a new particle. That just means it could be dust, or possibly not hydrogen gas, because you can generally see that unless it was neutral. And by modeling the density, you can actually generate the correct rotation curve. But you see, this shows you now you have just there, you have three theories. You have the standard Newtonian with halo dark matter, and you have the two other ones I've just mentioned, all describing the same observations. This is the underdetermination in astrophysics in this case. But the other scale, that was the large scale of Newtonian gravity. Then there's the microscopic scale. So there are experimental techniques, or experiments being done down to centimeter. I don't know if they've got to millimeter scales, where they've been trying to measure the gravitational force law on the tiniest scales. Because once you get into the quantum realm, Newtonian gravity, we all know, can't work, because it's a classical theory. It's not a quantum theory. And so on that end of the scale, when you get down to quarks and subatomic particles, we need a quantum gravity theory. And there have been a number of them proposed, but none of them have successfully produced anything. And that's possibly where string theory comes in, M theory, brain world theory. You get up to multiple higher dimensions, 11 dimensions, or 30 something dimensions. You know, it depends on your imagination, how far you want to go. So that's because we have not been able to test Newtonian gravitation, say below, definitely below a millimeter in scale length. We haven't. So I acknowledge that. See, they're the limitations of the theory. I'm not saying we've got an absolute perfect theory that applies on all scales. If we acknowledge those limitations, then we can use the theory over the realm of that. I would say without proof, as part of my belief system, God is the one that knows the perfect theories of physics. He knows them all, and they may be quite complicated, and maybe none of what we have are anything but a small approximation to those universal truths. But it's fun. It's fun trying to discover those anyway.
Yes. Are you ready to go on?
Yeah, sure.
Are you getting tired?
I'm okay. Remember, it's morning for me here. Yeah.
Okay, good.
Okay, so now we're moving on. This is now more devoted to cosmology than the more general science. And so cosmology is really about the structure of the universe, and cosmogony technically is the history. And they are woven together. They are definitely woven together. But galaxies are seen in different forms and shapes. And so it's like, as I said, it's like stamp collecting. Astronomers will catalogue these galaxies with their properties, and they will test models on the evolution of galaxies and the large-scale structure, that's cosmology, and history, cosmogony of the universe. Now, they can't look with their telescope at a galaxy and see it evolving from some baby form to a large, what they would call a mature galaxy. The reason I call this it's like stamp collecting, because what they will do is look for, say, go to high redshift, where the theory says we should have baby galaxies, sort of not so well formed, much smaller in size, mass and luminosity, and compare them to a collection of galaxies at low redshift in a, say, galactic neighborhood, where they should be large, evolved, bright, and have a lot of metals. Metals meaning elements greater than lithium. And so that's the stamp collecting. That's the comparisons that are being made. But you can't really watch the evolution of a galaxy over millions of years. Now, there have been some projects that will observe them over over lab timescales, but the changes are very small, of course. But these are not the scale lengths of the proposed age of the universe. So there are 5 big questions here. And I think these are important questions when we're talking about the cosmos. The answers to these are pretty critical. Number 1, I'll just read them and then we're going to go through them. So, does the universe have a center and an edge? Number 2, is our galaxy in a special or privileged location in the cosmos? 3, is the universe observed to be expanding? Number 4, are galaxies observed evolving? Number 5, what do we really know about the cosmos? I mean, when I say that, I mean actually know, something we can call facts. George Ellis, a South African cosmologist, he said people need to be aware that there is a range of models that could explain the observations. For instance, I can construct you a spherically symmetrical universe with Earth as its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there's absolutely nothing wrong with that. What I want to bring into the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that. So this is again back to what I started out with here. This is really philosophy, which is another way of saying a religiously held belief system. His comments are all linked to a philosophical worldview. And based on that worldview, one decides to believe or disbelieve any given cosmology and hence cosmogony of the universe. Right? Now, I'm not saying this is only for a secular belief. I'm saying this is true of all believers, one way or another, whether secular, atheist, religious, of any religion, whatever. It applies to everyone in this universe. There is no unique description, and maybe that's this point of underdetermination. The notion of the expanding universe and the application of the standard LCDM model, that's dark matter, dark energy, dark matter, Big Bang cosmological model, has led to many contradictions and many fudge factors. We can pick and choose because there's no unique description of the universe. The reason for this is philosophical and not empirical. So we bring our worldview to that observational evidence. The evidence itself cannot uniquely exclude all other theories, models, and say this is the one. It's not possible because of underdetermination. That's like the blind men and the elephant. Well, it's close. It's not really quite, but nearly there. All models presented in order to make sense of the stamp collection, are with the bias of the presenter. There are none free from his or her belief system. Now, that sounds like religion. Well, it is. I'll tell you another story. I spent some time with my colleague when I was at University of Western Australia, where we wrote a paper comparing man-made atomic clocks, and we're working in the time and frequency area. That's what most of our work was involved with, in optical clocks and microwave clocks, cryogenically cooled, ultra-stable clocks, this sort of thing. So we spent a lot of our time at time and frequency conferences around the world, rubbing shoulders with people who built some of the best cold atom clocks. And they were getting to accuracies of parts in 10 to the 17, 18, and stability around 10 to the 16, part in 10 to the 16 stability. These are just incredible. So we wrote this paper comparing the whole different range of different types of clocks. These are like the best lab-based clocks I'm talking about, not commercial clocks, to what the astronomers claim is the best clock in the universe, which is the pulsar, a rotating neutron star that emits a beam, a radio beam. And they are very useful in astrophysics because they're in the universe and they can be used as for timing in the universe. But on short time scales, they're very, very noisy. They're very poor. They're not accurate because they're not connected to the definition of the second through the cesium atom. And on short time scales, they're incredibly noisy. But as you average for longer time scales, like out to like 10 years or so, they improve. And so we wrote this paper and eventually got it published in Reviews of Modern Physics. Reviews of Modern Physics has an impact factor of over 40, whereas a typical journal is about 4. So this is the one of the 3 top physics journals or science journals in the world: Science, Nature, and Reviews of Modern Physics. And we got it published in there after a long haul, fighting with reviewers, and eventually they agreed. I went to a pulsar conference in Italy somewhere, and it was a whole group of pulsar scientists working together. And there was the famous lady who right now I knew I was going to forget her name. She was the early discoverer of the pulsar. And she had written in a paper that these were better clocks than any man-made clocks. Made quite famous claim to this. Maybe it's good I don't remember her name for this point. She was sitting in the front row when I gave my talk, presenting my evidence and showing the comparisons. And even though this was published in, let's say, the 3rd highest impact factor journal in physics, no one at that conference came to me afterwards and said, that's amazing. And the reason I'm saying this is worldview. They all had their vested interest in their worldview, that the quasars are the best thing since sliced bread. No one commented to me. In fact, I felt like I was a lamb in the midst of wolves or something like that. Maybe not a good analogy, but they were fair. I'm not saying they were bad people. I'm not saying that. But I was certainly a duck out of water. But I'm saying it's worldview, because everyone has a worldview, and that's their belief system. So even though we got that published in that journal, they would never cite it, they would never recognize it, they would never discuss it. So I do recognize this limitation, And I choose my worldview and hence my cosmology or cosmogony using the biblical description from the book of Genesis. So I say, if my cosmology is not consistent with that history, then there's something wrong with it and it should be rejected. Now, I've looked for different cosmological descriptions in the past and published on these, and if I couldn't find a consistent view with the book of Genesis, ultimately I've abandoned it. Now, that's what I've often been criticized for by others in the cosmology community, that because I do hold to a biblical creationist worldview, I'm not to be taken seriously. Okay, so back to our questions 1 and 2. Do you remember what they were? Does the universe have a center and an edge? It's a big issue. And is our galaxy in a special or privileged location in the cosmos? About a center and an edge, when you think about it, people generally logically think that if the universe is expanding and everywhere you look out in every direction out from us, the galaxies are progressively redshifted, then it would appear like we are at the center of that universe. Well, that's what George Ellis was speaking about when he said he could construct that spherically symmetrical universe with us at the center. So he said that's a philosophical point of view. And the other one is our galaxy then, we're not talking about our planet, we're talking about our galaxy in some privileged location in the cosmos. Like God created us and put us here in a special place. But these are both philosophical worldview questions. So really the answers are to the preference of the observer. You can choose. I would say that personally, I believe the Creator put us somewhere near the center of his creation. That's so that we can see it all around us. But no cosmology could uniquely tell us that. We cannot use cosmology to show that that is the case. Do you have a question on that?
I have so many questions. Well, I guess I'm wondering, like, what you mean when you say no cosmology could uniquely tell us that. Like, because couldn't we possibly rule it out, like, by our observations?
Yes, you could. You could rule out cosmologies. In principle, you could use observations to rule them out. But when I say can't uniquely tell you, if all your observations are, they're not even galactocentric. The observations are all Earth-centric, or if you've got a satellite like James Webb at the Lagrange 2, I think it might be. Let's say that's solar system centric, or centric to our sun. We don't have observations from any other perspective in the universe. And so you can construct models. Observationally, they would have to be consistent with an apparent Earth-centric universe.
You know what's interesting about this is that when I was reading Hubble's book, and he had just, basically done all the observations of the distant galaxies and the redshift and everything and kind of cataloged it, he was like saying, look, this could mean that Earth is at the center of the universe because there's redshift all over. But he said we have to avoid that conclusion. He was looking for some other way to explain it. And I'm not saying we are. I'm just saying that was one of the ways that even he realized this could be interpreted. And several times in his book, he said, we have to avoid that monstrous idea. And
he used the word horrendous or something like
Yes,
that, didn't he?
yes. And then that brings me to, isn't one of the, because I know there's some kind of principle, is it the cosmological principle that like, what's the name of the principle that is more of a philosophy that like basically that we actually go by in cosmology, that we say
Yeah.
Earth can't be in a special place? What is the name of that?
Yeah, that's it. Cosmological principle. And we'll
Okay,
get to that. We're going to
perfect.
talk about that. Yeah. So let's keep going then.
Sounds good.
Okay. So to give you an example of this idea that our observations from Earth may, how would you say, you may erroneously conclude that we're in a special spot because the observations all point back to Earth. And one effect is called the finger of God effect. It's pretty amazing, isn't it? It's called the finger of God effect. So if you look at this particular image, this is a map, a segment of the sky. You see the angle there. It's looking in a certain angular size. And on the right-hand side are redshifts. So this is a redshift space, kind of redshift space, but has angle component. So the radial component is in redshift and the angular component is in degrees across the sky. The red section is a cluster, galaxy cluster, and it's called the finger of God effect because the cluster seems to be elongated, pointing back to the Earth. Right? So this is in redshift space, really not in real space, because we don't measure when you get out to the clusters. That's a large cluster there. Every dot is a galaxy. When you get out to that scale size in the universe, you're basically only using redshift as a distance measurement. And I've simulated this to try to explain to people what this could mean. Now, if you constructed this is a cluster of 1,000 galaxies, and this is in rectangular coordinates, even though this is in a redshift scale, like a box in redshift scale, we can say this is real space because it's just scaled by this factor, speed of light over h naught, Hubble's constant. So that's like a real space projection of that cluster. Of course, it's flattened into 2 degrees, into two dimensions. And where 0 is the observer. That's Earth, with our telescopes. Now, this is a simulation. There's no redshift added at this stage. This is just the real space. It's not in redshift space, even though it's in the units of redshift space, just by a constant scale factor. We haven't got any motion within the galaxy of each individual galaxy. That's each dot is not moving in that within that cluster. It's all just sitting there. Now, if we go to the next one, this is the same one. The top one, number A, is exactly the same as the previous one. It looks a bit distorted because of the scale length of the box, but it is still the same. You could still say that's a real space image, but described in redshift space units. And now in B, the second one, we've added a orbital velocity component. It's random to every galaxy. 1,000 galaxies all now get a random motion within the cluster of 1,500 kilometers per second. And we're looking at it in redshift space. These are units of redshift. And so because that's a radial component. The only redshift we can see is the radial component towards the observer. It starts to look elongated towards us in redshift space. And then we add the last one, C, 15,000 kilometers per second. The whole thing is elongated enormously. That's the finger of God effect in redshift space. But my argument is these motions that we've added are random motions within the cluster, whereas actually you go back to A is closer to the real space image of the galaxy, because even though this is in redshift space, in real space, the motions are all internal to the cluster. There's no stretching out or finger effect in real space. It's just the Doppler motion, Doppler redshift, or it could be blue shift, goes both ways, of the internal motions of those galaxies within the cluster. So you could say, and I've had people tell me this, oh, that's proof that these galaxies are all pointing, the clusters are pointing back at the Earth. Now, you could argue that that's true, and there's no other way to argue against it in absolute terms, but by modeling it, you can see there's another explanation that the galaxy cluster actually looks like this in real space. It's just those galaxies are individually have random motions all around through that, but we can only see the radial component toward us or away from us, red or blue shift, of those random motions within the cluster. Whereas the cluster itself, its center of mass motion in an expanding universe would be moving away from us, and the center of mass motion then of the cluster would be redshifted in an expanding universe. But this highlights another point, though. You're only measuring redshift. You're not actually measuring those kilometers per second of the galaxies in the cluster, or even the center of mass motion of the cluster. That's an interpretation of what the redshift actually means. So this highlights the fact it would be nice to say, I believe the finger of God effect is a real space effect, but this explanation is very logical and reasonable, and so I don't believe it. So that's still then a worldview issue, right? I'm saying I don't believe that that is the case here. We have a reasonable explanation. And we do know, and this is an important point, we do in a lab measure the Doppler redshift, red and blue shift in lab experiments. It's very common in optical experiments, very, very common. We correct for it with the GPS satellites because they have a time dilation effect due to their relatively high speed as they move in low Earth orbit. So this is that aspect, Doppler shift, is experimental physics. Okay, what was our question? It's been masked a bit. Do we observe the universe to be expanding? That ties in nicely with this issue to do with redshift. You see, because we only measure redshift, it's impossible to answer in any definitive way. All evidence is equivocal, and the same observer biases are involved in selecting the observational data. So what does the redshift of galaxies actually mean? Now, I have a friend who's catalogued, the last time I looked, he got up to 39 different mechanisms that can cause redshift. And to my knowledge, I might be wrong, but to my knowledge, only one mechanism has not any lab experimental basis or evidence, and that is cosmological redshift, the one that's used in all cosmology and an expanding universe. So how can you be certain that that's true? Even Hubble in 1935 he even doubted that himself. He even said that possibly redshift means something else other than cosmological expansion. I'm not saying that we can rely on any individual, but I mean, Hubble would have been given the Nobel Prize if in that time the Nobel Committee recognized cosmology as physics. They didn't at the time, and they didn't give Nobel Prizes to anyone in cosmology. It just shows the another aspect of human behavior. So, and also if we then look at the Bible, there are 17 quite famous biblical texts that people have used to argue that the universe is expanding. Well, I've looked at those texts, and looked at the Hebrew, and looked at the grammatical context and the historical context, and there's no way that the meaning of those verses where God used expressions like spread out or stretched out like a tent or a curtain, they were in the context of what the readers at the time understood. They traveled through the desert. They put up their tents and their tabernacles. They put up curtains. These are not stretchy things. These things didn't expand by, if you go back to redshift of like 7 or 14 nowadays, that would be like a expansion factor of 15. You can't take a tent and expand it 15 times. It just doesn't happen. That's not the context. Certainly not the rubber balloon context that we see described in cosmology. And then if you add on inflation, you can have a 10 to the 26 expansion factor in the early universe during the inflation period. So can be no argument that the Bible is describing cosmological expansion. But again, of course, this is a worldview issue. It's what you choose to believe is true. So for redshift to mean expanding universe, I say that implies a logical fallacy. So it would be circular reasoning to say the universe is expanding because most galaxies exhibit redshifts and the magnitude of their redshifts are proportional to their distance from us. See, redshift is used to measure the distance within this assumed cosmology. So if the cosmology is assumed to be expanding, then there is circularity. Because you would have to have a mechanism to show that the redshift of the galaxies means that the universe is progressively getting larger. But what in actual fact is used is, like with the type 1a supernova, for example, you use them as a standard candle, and that's a brightness or a luminosity versus redshift calculation, comparison. And you say, well, that fits our theory. As the redshifts get higher, the luminosity goes down. And therefore, those galaxies must have expanded out, from lower redshift, where they're more luminous, to higher redshift, where they're less luminous. Very difficult, of course, to do, to find the standard candle. I would debate the whole type 1a issue is a standard candle, but the circularity is that you assume the cosmology to be true, because the reason you have to do this is because to calibrate those standard candles that you're using, you need to know the cosmology, because you need to know what their absolute brightness is in their rest frame, in their center of mass rest frame. If you don't know that, then you've got your circular argument complete. You've completed the circularity, you see. So
wow, that's a great thank you for explaining that, because that is I that's a revelation to me. That's amazing.
So what Adam Rees and others did when they published their papers in 1998, the claim was they had that type 1a supernova, so that's some type of a white dwarf star that goes supernova. And they believed that the bounds of the range of the energy being released from that supernova was so tight that the luminosity of that supernova was standard, that it was all the same. And they find them in galaxies at different redshifts. And then they look at their light curve. That's the curve as a function of time of the luminosity. So you see it coming up, getting brighter, and then over time fading away. But the truth of the matter is that's not the case. They measure those light curves, and if you were to take them and lay them on top of each other, they will not all be the same. But if they were all exactly the same standard candle, that should happen. And then say, oh, wait a minute, we need to do a correction. The correction is time dilation. Because of higher redshift, you have a time dilating factor. And so then they will apply that time dilating factor to them. That also implies they've assumed an expanding universe, by the way. They're assuming some detail, maybe not the particular cosmology, but it has to be an expanding universe cosmology. So they'll do that correction. And then do the light curves all lie on top of each other? No, they don't. And so they do another correction, it's called the stretch factor, where they actually stretch or unstretch the light curves so that they all lie on top of each other. And they say they recognize a spectrum or variation amongst that standard candle that they have to correct for. And there are some that they've had in their collections, their stamp collections, where they've thrown them away because they didn't fit. So there's the bias of the observer. And, you know, Adam Rees might have called his supervisor and he said, oh, no, chuck that one out. And that's actually what they do. I mean, it's not secret. They actually say in the publications, the ones they excluded. This is the problem, though, of this problem of stamp collecting. How do you know you've got your perfect set of all 1 penny blacks? How do you know they all are? There might be some 2 penny whites or some 5 penny greens in there, and you're assuming that they're all the same in your collection. But that's the problem. And so you now have this circularity in this problem.
Wow. And so we were talking about that because for those who are watching who don't know who Adam Rees is, this is the person who supposedly I put in quotes, discovered dark energy. And it came about because when he was doing the calculations with the supernova, he ended up coming up with a negative mass for the universe.
Yeah.
And so you were saying, Dr. Hartnett, that on normal circumstances, at that point, you realize something is wrong with the whole model, right? Like we wouldn't have a negative mass of the universe. So let's figure out what's gone wrong with the model. But instead of figuring out what's gone wrong with the model, they decided to make up an invisible force that somehow suddenly kicked in to make the expansion of the universe, which is already something that's, you know, proposed but not known, but then that something suddenly kicked in a few billion years into the universe to make the expansion go faster. We have no idea what the properties of this thing are. We don't know. And so it's a completely made up thing. So that's what happens when you start with the model and you're dedicated to it, like you're talking about.
So to save that model, they added back in the cosmological constant, which was in was something that Einstein had used in his early model, in his early cosmology. And when he heard that the universe was expanding, when someone told him, Hubble or someone told him it was, he threw it out. The reason he had it in there was the opposite. He thought the universe was actually contracting, and so he would add in this cosmological constant to sort of balance it, to give it a bit of a outward pressure to keep it static and stable. So then he threw it out when he heard that it was expanding. Yeah, so to add to the point is, now that they've added back that cosmological constant, and Adam Rees in his Nobel lecture actually mentioned that this characterizes something like vacuum energy density, energy in the vacuum. Particle physicists have made those type of calculations, tried to calculate what the energy density of the vacuum is. The numbers they get are stupendous numbers, and it depends on what wavelengths you do your cutoff, and there are various factors. But compared to the cosmological constant, which is incredibly weak, tiny number, they get the opposite side. They, instead of get like 10 to the minus 50 in C equals 1 type units, they will get in particle physics, they will get like 10 to the 50 units of energy in the vacuum. And so that meant 120 orders of magnitude error in the calculation of that constant, which is the greatest. It's been said, not by me, but by theoretical physicists, as the greatest error in history of theoretical physics. And no one has yet been able to resolve that issue. Never been resolved. Okay, moving on. Question 4. Are galaxies observed to be evolving? So this is again a subject of circular reasoning. Evolution in size assumes a cosmology. So growth of a galaxy is allegedly shown by its absolute magnitude. That's the brightness. But to know that, you have to know how distant it is. You have to know how distant it is so you can calculate what its absolute brightness is. That's in its rest frame, right? And this in turn is linked to your chosen cosmology, because the cosmology will give you, as a function of redshift, what the distance is. So this is totally circular reasoning again. And evolution of galaxy size and the well, there's a few other things too, but metallicity is related. Metallicity means the concentration of these elements in the galaxy. The growth in size is used as sort of a control knob. So you can say, if a galaxy, the best way to explain is like this. It is, if you assume there's a certain distance of the galaxy based on its redshift, and its brightness doesn't match what the theory says it should be for a certain size galaxy, certain angular size, then you turn the knob, it's like a control knob, and you say the galaxy either evolved faster than we expected or didn't. So that becomes then an adjustable parameter. So I note that just recently a James Webb telescope spotted a redshift galaxy of 14, which is claimed to be 300 million years after the Big Bang. But, well, it has oxygen in it, number one. That's a big problem. But that evolution of galaxy size then has to be used, because they say, oh, how could this galaxy have evolved so much to produce these metals? That's what I'm saying. Oxygen is considered a metal. I know it's crazy, isn't it? But anything above helium, hydrogen, and lithium is considered to be a metal. And they observe oxygen in its spectrum. So then you turn that knob and say, oh, they evolved faster than we ever imagined. And they're shocked. They're stunned. How can this happen? But this is storytelling. This is what this is. That's why I call it just good cosmic storytelling. And you just turn that control knob.
Yeah, a few years ago, you could look online and it would tell you that a spiral galaxy takes 7 to 8 billion years to form.
Yeah.
And so now you cannot find that anywhere on the internet because it has been scrubbed, but that was a fact. That was a fact back then.
Yeah.
So you couldn't argue with it back then, but now it's scrubbed because now we find the galaxies that are, supposedly toward the beginning 300 million years after the Big Bang. So yeah, it's really...
But that's how cosmic storytelling works. It's a very rubbery story. It's very flexible. And they have that expression, oh, we now know. And that's used everywhere because some new information and that doesn't fit the cosmology. Oh, we now know. They evolve much faster. Now we have a whole new investigation to find out, this sort of thing. Instead of saying, oh, this doesn't fit the theory, this is wrong, the theory is wrong, chuck it out, go back to the drawing board and see if we can explain these observations.
Yeah, and I think we're perfectly fine with people making new discoveries and admitting they were wrong about the other discoveries. It's just our complaint is that whatever they think is true right now, they demand that people believe this. This is fact. If you don't believe this, you are unscientific. This is what the science says, right? And so it's the demand, it's the dogmatism right about what they think they know right now.
So it's their religion, right? It's their belief, their religious belief system that they have to hold to. Yeah. Okay, so now we're up to this point of the cosmological principle. So underneath all cosmological theorizing is the assumption that there's no privileged location in the universe, and that no matter where you might hypothetically place an observer, he will see essentially the same structure of the universe on a sufficiently large enough scale. Now, how could you test that? You couldn't, because they're saying anywhere in the cosmos, if you observe the universe, you would see the same structure on a sufficiently large enough scale. And that highlighted, bold and 4 words is the get out of jail free card. Because if that were not true, if that didn't happen, you just simply say, oh, that's not sufficiently large enough scale. And we know also from some of these very large galaxy surveys that are now the computerized surveys that are now mapping a 3-dimensional cosmic web of filaments and voids, amazing pictures of these structures. I don't know what size they have to get to say that it is, any observer in the universe will see that on those scales, large enough scales. So this is circular reasoning, is untestable assumptions, and as I said, the distribution of galaxies is not isotropic and not homogeneous. Definitely not homogeneous. I mean, the cosmic web alone disproves that. And isotropy is another issue. We see more galaxies in the northern hemisphere, the northern celestial hemisphere, than south. We see there's a preferred spin orientation, north and south, 50% more spin one way than the other way. There's a lot of inhomogeneities, or let's say the negative of isotropy is not isotropic in certain directions. well, in any direction if it's not the same in every direction. So that's part of the problem. But also the cosmological principle is that the laws of physics are the same everywhere in the universe, so that we may apply our models using known laws everywhere. But this is also contradicted by the insertion into the models of made-up stuff like dark matter and dark energy. I mean, I think with the dark energy, I think the kickoff redshift is something like 0.5, redshift to 0.5. So higher redshift 0.5 is later epoch in the universe, and it's not needed. You know, at higher and higher redshifts, you measure higher and higher redshifts, and therefore you measure as time goes on. You have an expanding universe. But the dark matter issue we talked about already, locally totally unknown. Dark energy is locally totally unknown. There's no lab experiment that ever detected anything like an anti-gravity or even a vacuum energy density of that nature. I mean, these are totally unknown in the solar system. However, that is required for the models to be tested. And the need for fudge factors, this is dark matter and dark energy, is an admission that the Big Bang cosmological model is wrong, and or that the assumption of the physics being the same everywhere is wrong. So it is possible the physics is not the same. I don't discount that. But that does discount the cosmological principle if you then assume the physics is not the same. Why isn't the standard model, Big Bang model, thrown out? Because it's a religiously held belief. You can't throw it out. Therefore, testing models on the cosmos is an attempt to determine the large-scale structure and therefore also the history of the universe is based squarely on the belief system of the researchers. It's religion and not science. That's very important to understand that. And look, I'm not saying that a scientist can't be religious. I would say that's true of me. I hold to a biblical worldview, so people would say I'm religious. But I'm saying I recognize that it's not science. Question 5, what do we really know, therefore, about the cosmos? When I say really know, I mean, what can we say are facts? Obviously, observations we make are facts, but what are the textbooks and the research papers telling us that you should believe? That's really the issue. But you need to believe it. If you're operating in a certain field, say you're working in a research field, then for you to succeed in that field, you have to believe it. You have to publish in that area like you do believe it. So you have to be in a kind of a club. You have to be in the Big Bang Club. You try to publish a research paper that goes against the Big Bang, and you will have a very, very hard time publishing in any leading journals. Now, I say very, very hard. I don't say it's totally impossible, because myself and working in an area that's alternative to Big Bang, and that's Fred Hoyle, Jeffrey Burbidge, Alton Arp, in the decades ago, spoke about quasars being ejected from parent galaxies. And in the last decade or more, I've been working, he was actually my Ph.D. student at UWA, and co-authoring with Holton Arp and myself and Chris Fulton, he's the guy that's the computer whiz. We have been looking at the association of quasars with putative parent galaxies based on the large databases that are now available through these large galaxy surveys, galaxy and quasar surveys. And the first one was published in the Astrophysical Journal, which is the top-ranked astrophysics journal, and took 5 years, I think, or 6 years to get published. And the next paper took 4 years, I think, rejected from Astrophysical Journal after 3 years, and eventually published in Astrophysics and Space Science. And now we're working on a third paper, rejected from the monthly notices, the Royal Astronomical Society, and we're trying another journal. But these are very, very hard to get published because it's anti-Big Bang. And the very fact that we've even got a few published is amazing to me, absolutely staggering. So the normal case would be you have to speak the, I say, nonsensical, anti-biblical worldview of the universe creating itself out of nothing, else you cannot be successful. Now, these papers I've worked with ARP and Chris Fulton, they're not Big Bang, it's static universe, but they're not per se biblical creation, but I can actually see a creation process in them. So that's the reason I pursue that. However, the standard secular cosmology is that the universe created itself out of nothing, absolutely nothing, I mean, really nothing. And you'll find this written in Wikipedia. This is in reference to a book written by cosmologist Lawrence Krauss. They write there, A Universe from Nothing, this is the title, Why There Is Something Rather Than Nothing, is a non-fiction book by a physicist and Big Bang cosmologist, initially published January 10, 2012 by Free Press. It discusses modern cosmogony, the history of the universe, and its implications for the debate about the existence of God. Who says it's not religion? I mean, they just say it right there about the existence of God. Remember, this is meant to be science, you know, the white lab coats and all that sort of stuff. So this is a worldview issue on full display. It's not science. And the Krauss universe made itself. He said it came from absolutely nothing. And when he says nothing, he means not space, not time, not energy, not vacuum, not anything. And suddenly it spontaneously appears. Don't tell me they're not religious. Well, here's another cosmologist, me. The only worldview that makes sense to me, in my opinion, is that God created the universe essentially as we see it today. So God, the creator, is the self-existent one. He was not created. He exists. He transcends space and time. And the universe has changed very little in the last thousands of years, not billions of years. We see it all in real time. There are no billions of years of evolutionary history. However, I recognize that this is philosophy and not science. This also applies to all models, whether we be from atheists or theists, Big Bang cosmologists, biblical creationists, or anyone else, any other flavor of any kind. I accept that and I recognize that. And that's where I'm stopping.
Awesome. Well, do we have time for a couple questions?
Sure.
Okay. Well, and first, I just want to make a comment that this universe out of nothing, I think they're kind of catching on about how nonsensical it is. So now it's like that idea of it coming from nothing is fallen out of favor. So now it's, no, you see, we're in these endless cycles. So, and so it's just really interesting. But I mean, it
Well, they even have Rebecca, they even have an eternal Big Bang universe. So the idea is there was this eternal quantum vacuum that was hanging around, a metastable false vacuum. So it's sort of like, it's like you imagine you can cool a liquid. If you have a very pure liquid and there's no nucleation site, like a crystal in it, you can do this with water. You can freeze it below freezing point, but if you put a bit of salt in it, it will instantly freeze. It's a nucleation site, even though you were well below the freezing point. So a metastable false vacuum is something similar. That's an analogy. So that hung around for eternity. No time in the past. It's been there forever. And then one day, some little fluctuation occurs, and out pops the universe. And that's as a Big Bang universe. So that's sort of importing the steady state theory that had no origin in time, and they're adding a Big Bang origin into a sort of a steady state universe, because they got to get rid of the origin in time. They got to get rid of an origin, meaning if it had an origin in time, then maybe it had a creator, and that is abhorrent to them.
Yeah, well, to each his own. Everybody can believe what they want to believe, and
Sure.
but I think our view is good, that God created, and but I wanted to ask you about star formation, because you mentioned, this idea of we can't watch galaxies evolving over millions of years, but some people have tried to at least watch galaxies over a period of time, and I wanted to know about star formation in that time of watching galaxies. Have they ever seen a star like come into existence? Because
No.
I mean, they right now, if you look on star formation, they'll be like, look, star nurseries, picture, and they'll show like stars in a nebula or something, and they'll be like, look, it's a baby star. But then it's like they have this whole assumed thing. But I mean, do we have any observations of like actual a star coming into existence?
Not to my knowledge. You're right. So in a nebular cloud, they will show stars burning bright, high, very strongly in the ultraviolet or blue part of the spectrum. And they'll say that's new baby stars that have condensed out of the gas and dust. But no, so what you would need is to see a nebula as a function of time, with dust and gas, and then you're continuing to watch it, and then suddenly you get a star burst into life as you're watching it, and then you would then say, that's a star forming, right? Now, there is a possibility that you could have a gas cloud with elements like dust and heavier elements in that gas, and you had a supernova nearby that caused the cloud to be shocked, like a shock compression, and you could overcome the Jeans limit, which is the natural limit due to the Jeans law of compressing a cloud of gas that will heat up as you compress it, and that will normally limit the compression, but by having enormous pressure applied from the shock wave of that supernova, it's possible. I'm not saying, I've never heard of anyone saying they've seen it, but it's possible you could get a star forming like that. But that's not the problem. The problem is you have to have a whole universe of stars form right from the early Big Bang universe of only hydrogen and helium, a bit of lithium. And how does that happen? How does it condense down? How does a molecular hydrogen cloud, this is neutral hydrogen, How do you get that to condense down under gravitation alone to get hot enough for fusion reactions to start? You can't. All laboratory physics says it's impossible. So you have to invent dark matter. Dark matter is the answer because it gravitates, but it doesn't interact, or extremely low interaction cross-section with normal matter. And so then you don't get that problem with the Jeans limit of that increased pressure. You just get it's like you could say the dark matter creates the gravitational well, makes it deep, so the normal matter, the baryonic matter, can fall into that deep well and then get compressed and fusion reaction can start up. So dark matter is the god of the gaps. Dark matter is the unknown god that solves all the problems. That's the problem with it.
I see. Okay, this question came in. It was how many of these white dwarf novas do we observe? Is there enough to make up significant data? So I think he's referring to when you said we don't really know what like these supernovas.
The type 1A class. Okay, so there are many supernova observed. Yes, there are. They're observed in the galaxies all around us at a certain rate. And they're another stamp collection because they're categorized into different classes. So when we say type 1A, that's a certain class. So there's type 1, but they're divided into subtypes. And the type 1A is, they believe, they understand the physics of it. Now, I think in the collections that 1998, look, I can't remember the numbers, but it was something like about 100 or so were used in the data analysis. So there will be many hundreds indeed, that are observed and analyzed at different redshifts. So they're found in galaxies because they're very bright, right? Bright source. And so even if the galaxy itself is very faint, the supernova is very bright. Now, nova is not the same. A nova is actually, a supernova is basically the white dwarf blasts itself apart and leaves behind a neutron star. That's the theory anyway. Has a mass of about 1.4 solar masses and blows off about that 40%. And in that, of course, it builds heavy elements above iron, so right up to uranium, all the heavy elements. But the nova is where a star may not be a white dwarf. It undergoes a similar kind of reaction of shells. This is the theory, shells of the metals building up, and it blows off some of the outer layer. It's not so bright, and the star remains visible after it blows it off. So it's different classification. I think recently, if I remember reading on the web, there was a case of a white dwarf. No, sorry, that may not be wrong. I was trying to think of a case of a white dwarf supernova where they could see a neutron star left behind. Now, you could search that, but I'm not sure. No, I won't say that because I'm not sure if that's correct. But that's what you would have to observationally see to even know for sure that that is the process that occurred, that you had a white dwarf left behind.
Now, I wanted to ask you about supernova because I've heard this argument about, and you've been around these arguments for a long time, so maybe you've heard of it, and I want to know if it's good. Do you think that, the argument is that we should see more supernova, a lot more, if the universe is billions of years old, like our observations of numbers of supernova and at supernova at certain stages, like we should see a lot more, it like basically a third stage supernova at this point.
I think that's remnants is what you're
Yeah.
talking about. Supernova remnants.
Yeah.
There is an argument about the frequency of supernova, and the argument was usually about in our galaxy that we've had a deficit of supernova in our galaxy. It was supposed to be one every, I don't know, every century or so. Look, I don't know the numbers, but the frequency was, we're overdue. But what you're talking about is the counting of the remnants, supernova, type 3 supernova remnants. And there is definitely a deficiency of those. Now, I haven't looked at that stuff for a very long time, but I still think that from when I did look at it, I think there were some good arguments there that there is a deficit of the type 3, which means the ones that's meant to be the older structures that came from them. So the argument was if you don't have enough of those large structures, then that means that there has not been had enough time passed in the universe, in those galaxies in particular, because of the age of the stars in those galaxies, to have those formed. I used to look at some of that type of evidence in the past, but I no longer consider that so important, because I make now the argument that the universe we see today is real time. So some of those other arguments were made on the basis that you're looking back into the past. Say you're looking at Andromeda Galaxy, what's that, a million or 2 million light years away. So the argument would be that it takes 1 million years for that light to get here. And so therefore you're saying that it's actually back in the past of that galaxy. So you might say, we don't see what's happened after that. And so, because the light hasn't yet arrived. And so then you speculate about what might have gone on. And the reason I now hold a different view to this is because of scriptural arguments. I believe the natural language of the Bible is telling us that when God said he created, like on day 4 of creation, he made the sun and the planets, but it says he made the stars also. And the implication is that if you were there, you would see them immediately. You don't wait for thousands or millions of years for the light to arrive. There's other verses that talk about things like when God calling the heavens, they stood up together. It was like an immediate response. And so there is no delay, no transit time of the light. And therefore my argument is, I said earlier, and this is a whole topic on this question, but we are seeing the universe in real time. We see it as God created it. And of course, the counter argument is then, well, what about the speed of light? Does it take 1 million years for light to travel 1 million light years? Well, the simple answer to that is, who has ever measured the speed of light coming from the galaxies? That's the one-way incoming speed of light. Who's ever measured that? The answer to the question is nobody has. It's never been done. In fact, it can't be done. The universe doesn't allow us to measure the one-way speed of light. So how can you make an argument about that when you can't measure it? You can't. In fact, we are free to choose. Based on physics, we are free to choose the one-way speed of light. Now, I'm not saying that is the argument. I'm saying that because the physics allows it, I say the natural language of the scriptures is that it is instantaneous, because that's how the Bible is written. God didn't write the Bible in a sort of a framework of taking millions and billions of years for light to arrive for us to see it. And so I can still say the universe is young, even though it's incredibly large, because there is no transit time in the reference frame of the Earth observer. And that's where we are. We're Earth observers looking at the universe. Not sure if I've strayed from the question here.
Oh, no, it's great. I feel like I wish I could keep talking to you for so much longer, but I know we're already over 2 hours. So
Yeah, we are.
is this a good time to stop, or
Yes, it is.
are
It's a
you
good
up
time.
for a few more questions?
No, it's a good
Okay.
time.
All righty.
We can do it again in the future.
Okay.
Yeah.
Well, yes, I hope so. Okay. Well, thank you everybody for watching. Appreciate you being here. And if you like Dr. Hartnett and what he has to say, please go to his Bible Science Forum. The link is in the description of this video. And he has a lot of good scientific articles on his website. So that will help you if you have more questions about cosmology and a lot of other topics. So thank you, Dr. Hartnett.
And I'd add, Rebecca, the point of the starlight and time, the one-way speed of light, many people may question that. So I recommend they go to my website, just put into the search box one-way speed of light or something like that, and there are many, many articles on it to explain it, because it is quite simple, but for a lot of people, they can't get their head around it. And again, that's because of worldview. We've been indoctrinated on worldview.
Yes, and I'm not going to ask this question, but I will give a little shout out to B.S. Lewis. Thanks for joining us. And okay, thanks everybody for watching. Take care. Thank you, Dr. Hartnett.
Thank you. Bye now.